Today's episode of Just the Tip is brought to you by CK Worldwide, the standard in TIG welding. Right now, CK is running an awesome deal on their MT200 AC/DC TIG welder now through the end of March. The MT200 comes with everything you need right out of the box to start TIG welding, except the consumables and gas. The MT200 is a complete TIG welding system capable of 5 amp arc starts and has a compact portable design and weighs just 32 pounds. And it's dual voltage, so you can run it off 115 volt or 220 volt outlet. And it boasts an easy to use interface to get you set up to weld in a flash. The MT200 AC/DC is the answer to both creativity and production-driven TIG welding. This innovative TIG machine provides the ability to quickly and efficiently adapt to dynamic welding situations while maintaining the quality of experience you've come to expect from CK Worldwide. Get your MT200 today for just $19.95, along with other genuine CK Worldwide parts and accessories through your local authorized CK distributor. Not sure where your closest distributor is? No problem. Head on over to ckworldwide.com and click on the Find a Dealer tab. It's that easy. CK Worldwide, the standard in TIG welding. Now let's get into the episode. All right, welcome everyone, and thanks for tuning in to this week's episode of Just the Tip. Last week, we debunked the biggest myth in welding, so if you haven't checked out that episode, go ahead and do that. This episode is kind of a continuation of episode 1. Today, I want to cover a few things that I see on a regular basis that can cause fluctuations and other issues in our gas metal arc welding or MIG setup. Whenever we set up the GMAW system, or any welding system for that matter, we want to set ourselves up for success. Meaning we want to stack the deck in our favor so that we don't run into any issues that can cause problems while we're welding. We've already spent so much time, getting everything prepped and squared up and fit up and everything. The last thing we want to do is kind of like bust out on the weld. I mean, the welding is the most critical part of it. It's the most technical part, so we want to make sure everything is set up in our favor so that when we pull that trigger or strike that arc, everything's coming out as pure and as true as possible. Now, there's a lot of things that we tend to overlook or we might disregard altogether because we really don't think that they matter, or we haven't learned this part of the system, or that it's always kind of been glossed over and, just think we can get by without checking these things. But in reality, the small stuff that we overlook tend to cause the biggest problems while we're welding. This is also called the Pareto rule. It's an old rule that applies to many things in life, and that's basically saying that 80% of our problems are created by 20% of the causes. So in other words, the small things, they kind of add up to create big problems. The first thing I want to talk about is points of resistance. Unwanted resistance in our welding circuit, it actually robs us of amperage at the weld. We all know that amps are the biggest factor in weld penetration, and that weld penetration is our ultimate goal. I've seen some really pretty welds bust out due to lack of penetration and lack of fusion, and the lack of fusion and lack of penetration is usually caused by inadequate amperage. So how do we determine where we're losing amperage? It's actually pretty simple. First, we need to check all of our connections. And one of the biggest common issues that I see all the time as an inspector and as an educator is a loose contact tip. Now, you wouldn't think that would be a big issue. We just, take the nozzle off, throw a contact tip in, snug it down with our hands, and then we're good to go. Why the hell would it matter if it's not a snug, tight connection? Well, the function of the contact tip is not only to guide the wire, but more importantly, it's where our wire becomes energized. It's where the wire gets its amperage from. So if we have a loose contact tip, we have resistance, and additional resistance in the welding circuit means a drop in amperage, which is counterintuitive to what we actually want, right? We want all the amperage that we set on the front of the machine, right there on the panel, to go to our wire so we can get consistent welds. But if the contact tip is loose, we're not going to get that. So think of a battery in your car or truck. What happens if you have a loose connection on the battery, i.e. our power source, and we turn the key and start the vehicle? Now the radio may come on, the dome light and headlights will probably work, so that means we're drawing current, right? But the vehicle doesn't start because we don't have all the amps that we need because the terminal is loose, causing resistance in the system and once again robbing us of amps that we need to start the vehicle, or in our case, achieve adequate weld penetration to our weldment. So make sure you snug up your contact tip so that you get consistent results with your MIG welds. Likewise, we need to make sure that all of our leads are snugged up as well so that we don't build up resistance on the welding terminals on the inside of the machine. So reach in there and make sure your leads are securely fastened. Following down with our leads, we can experience a loss of amperage and increase in resistance with our workpiece clamp. Now, you've probably seen this before time and time again. You're probably using some kind of cheap, crappy steel workpiece clamp that came with your machine, and that's fine. I mean, you can get by with it, but if you want to set your machine up for optimal performance, I highly recommend swapping that cheap, steel piece out for a good, solid brass clamp. They're actually pretty cheap. You can pick them up on Amazon for $20 to $30, or just go down to your local distributor. It's a really small price to pay when it comes to added performance in your welding system. Now, maintaining and checking our leads isn't just important in our gas metal arc welding system. This will be true for any welding process, so keep that in mind while you're stick welding and TIG welding and aluminum MIG and like any other welding process where you have to complete the circuit. You want to make sure that your leads are in adequate working order. And one way to check if we have built up resistance in our workpiece clamp or our leads is to just touch them once, after you've welded. Now, if the clamp or the lead is above room temperature, or in some cases extremely hot to the touch, we've all seen the videos on Instagram where the nut on the workpiece clamp is glowing. That tells me right there that I have a buildup of resistance and a loss of amperage. How the hell else is that stuff getting hot, right? There's amperage. Amperage, as we discussed in the last episode, amperage equals heat. So if my workpiece clamp or if my leads are hot in any way, I have a loss of amperage in my system and a buildup of resistance. One way I found it's super simple that I check, typically, as I walk through the school, that I check amperage or, built up resistance in the work leads or the workpiece clamp is I have a FLIR multimeter with a built-in thermal imaging camera that I walk around the shop with. And sometimes I usually find a couple leads that are glowing in the camera because of the loose connection in the workpiece. And it may be if the ambient temperature in the room's 80 degrees, it might be hitting 95. So it's not like a big deal, but I can tell that there's resistance built up in that system. And this isn't something that I'm recommending everybody run out and buy. It's just a quick way for me to check several machines at one time while I'm in the shop. So if you are a welding supervisor or something like that, you're checking on performance issues, you're in weld inspection, you're doing weld qualifications, it's a good piece of equipment to have in your arsenal. And I want to give a shout out to Nate Bowman for letting me know about this piece of equipment. It's really cool, super awesome piece of technology. Like I said, it's not for everybody. It's kind of a high dollar item. I don't recommend going out and purchasing that. I mean, just touch your leads, touch your workpiece clamp, see if it's hot. If you've got heat built up in there, you've probably got an increase in resistance and a loss of amperage in your welding circuit. We also need to check the clamp and leads are not damaged. Make sure that your leads aren't frayed or torn up. Anywhere where there's a connection on there, you want to make sure that's snug and tight, whether it's a quick lock system, make sure those are secured in there. Or if you have a nut on the end of your workpiece clamp or anything like that, make sure it's torqued down. If you have discoloration on any of the ends, like where the wires are supposed to be copper, if those are black or you got arc strikes or anything on there, go ahead. It's probably time to just cut it back and replace it. A lot of times, like I said, you can just cut that piece back a couple inches, strip off some new copper, run it back in there and crank it down. You should be good to go. Now, in some cases, you may have undersized cable for the amount of amps you're trying to weld with. And that's like a topic for a whole nother show, but just make sure that you have the right size cable for the amount of amperage that you're putting through there. And we can also lose amperage due to length of cable, but like I said, that's a topic for a different discussion. Just make sure your leads and your workpiece clamp are clean and they're in serviceable condition. I know working in shops and even out on the job sites and stuff like that, forklifts, equipment, new guys on the pallet jack, a lot of times they have tendencies to run over our leads when we're working. Just make sure, that your cables are free from frays. They're not all tore up and they're in good serviceable working condition. That's going to be your best bet. Now, the next thing is actually pretty simple and it has nothing to do with the machine itself. And if you're a new welder, you're going to want to pay particularly close attention to this next part. you have to maintain the appropriate contact tip to work distance. I can actually watch the amperage on the front of the machine and tell if someone's holding the correct contact tip to work distance, because if they're not, the amperage is just bouncing all over the place. Now, we have to remember that all of our wire feed processes are CV, meaning constant voltage. So that means the voltage we set on the front of the machine, it's going to remain nearly constant while we're welding. We're talking plus or minus a few tenths of a volt here. However, amperage can fluctuate quite a bit depending on your contact tip to work distance. It's highly dependent on contact tip to work distance. Many people just starting out have a tendency to hold a long contact tip to work distance. You know, they get the nozzle in there within about an inch and a quarter of the workpiece. They pull the trigger and it's just spitting and popping all over the place. And you experience more resistance because you have more wire sticking out. Now, because of this, we experience a drop in current due to the resistance because of the increased length of the wire. So make sure you're holding an appropriate contact tip to work distance. And the appropriate contact tip to work distance is going to rely heavily on the diameter and type of wire that you're using, as well as the mode of metal transfer that you're using. So whether it's globular, short circuit, spray, pulse spray, etc. Once again, the electrode manufacturer has spec sheets for all their wires, and it's going to tell you the ideal contact tip to work distance you should be holding while you're welding. Now, if you're using a welding procedure specification, that information should be on there as well. If you remember from the last episode, I gave you all some great resources to download in the show notes section. All that information is also available on the website as well under the episode title. So make sure you check that out. You can download those free resources. Like I said, you can get it right there on your smartphone. You can pull it up on Google while you're out on the job site or in the shop. You can also request free copies of these things from the companies. You can print off the specific pages that you need, put them in your toolbox at work. All this stuff's going to help. Now, within the consumables books that I'm referring to, you're going to be able to find the wire that you're using, the exact type of wire. And it's going to tell you the recommended contact tip to work distance based off the diameter of the wire type, and the mode of metal transfer. So typically for short circuiting, we're looking at about 3/8 to a 1/2 inch of contact tip to work distance. And when we get into a pulse spray or a spray, we should be holding about 1 inch. And with metal core, that range can go from anywhere from 3/4 to 1 1/4 inches. And, same with a lot of flux cores. However, there are some flux core wires out there that go up to 3 inches. Yes, 3 inches. That's not a typo. I mean, that's a hell of a contact tip to work distance. But if you don't maintain that, you're going to get that built up resistance. You're going to get a drop in amperage, and that's going to decrease the penetration that we're trying to achieve. So even if we have the machine dialed in correctly, if we're not maintaining that contact tip to work distance, we're not going to get the results we're looking for. So always double check the WPS or the specifications on that type of wire, that specific brand, to make sure you're holding the right contact tip to work distance. So let's go ahead and do a quick recap. Additional resistance in our welding circuit is bad because it robs us of the true amperage, the amperage that we set on the machine, based off of our wire feed speed and our voltage. Some of the factors that play a role in increased resistance are loose contact tips, and this is a quick fix, for anybody, and it doesn't take long to do. Get you a pair of Welpers, also known as MIG pliers. Quit screwing around with the cheap pair of needle nose pliers that's in the gang box or the toolbox, and get a pair of actual MIG pliers. Especially, if you're doing a lot of wire welding, go buy a pair of damn pliers. I don't know why this is hard for a lot of people to understand. This is something that you're going to use all the time. Anytime I switch over to wire fed process, I've got a pair of MIG pliers and a holster that I just clip on, very similar to a tape measure. They're like $16 on Amazon for a decent pair, and they're well worth the cost. I mean, it's a 7-in-1 tool. You can clean out your nozzle. You can tighten up your contact tip, tighten up your nozzle, clean out the possibilities are endless with this thing. So go get you an actual pair of MIG pliers and make sure you tighten up your contact tip before you get into welding. And also, one thing, I kind of skipped over, make sure that you have the appropriate contact tip for the wire that you're using. If we're using 035 wire, we want to make sure we match up that contact tip, to an 035. We don't want to throw an 045 contact tip on there and run 035 wire through there. You're going to get a loss of amperage in there as well. Plus, it's not going to run true. That wire's going to kind of swirl around a lot. So you want to make sure you have the correct contact tip for that wire that you're using. So make sure that that's nice, snug, tight, and it's the appropriate one for the wire. Next, we talked about loose terminals on our leads. And one thing I forgot to mention earlier is make sure that your machine is turned off, and better yet, unplug the damn thing while you're messing around the leads on the inside of the machine. Although you should not get shocked if for some reason the default output is set to on, you may get a good jolt if you touch the negative and positive at the same time. Or if there's a wiring issue inside the machine, you can get zapped as well. This happened to me before. I was just simply checking the terminals on a machine. The machine was turned off. I reached inside. I went to go tighten something up and I touched the inside of the machine and got zapped. And it's because somebody had wired the machine up backwards at the place that I was working. So I actually had to have the electricians come over there. They rerouted everything and it's fine. But just to avoid that situation altogether, I typically, from now on, I just unplug the machine and make sure it's in the off position anytime I'm messing around with the terminals. So make sure your terminals are nice and snugged up. We also talked about poorly maintained and undersized leads. So make sure your leads are in good working order. Make sure they're good and serviceable. They're not frayed. They're not tore up. They haven't been ran over. Tape off any areas that are exposed. I mean, that's just going to general safety. You don't want it arcing out on anything. And then just make sure that you don't have undersized leads. And like I said, we'll probably get into that in a whole nother episode, but you can do a quick Google search and find out what size lead you need or the diameter, what size cable you need for the amount of amperes that you're pushing through there. And then, cheap workpiece clamps that are made out of steel. Instead of that, use brass. Like I said, you can jump on Amazon, go to your local supply store, and they have all that stuff there. Get a good, solid, heavy-duty brass one. They're far better at conducting electricity than steel, so make that $20 to $30 investment and just switch it over. And then last but not least, once again, our contact tip to work distance. That's going to be the most critical factor. If your machine is set up and everything's running great, you want to make sure that you're maintaining that recommended contact tip to work distance, because like I said, if you're long arcing that thing in there, you got a lot of wire hanging out, you've got a big drop in amperage, and your weld's not going to get adequate penetration. So make sure that you're maintaining the correct contact tip to work distance with that. By checking over these 5 simple areas, we can ensure that our system is performing to its optimal potential. And once all these areas are checked and addressed, at that point, it's up to you as the welder and your technique. So try to keep these factors in consideration when you're setting up your machine. Most of the time people are having issues, they always want to blame the machine when it's actually a user issue. I say all the time, it's 9 times out of 10, it's the pilot, not the plane, meaning it's the welder, not the welding machine. So go through your machine every day at the beginning of the day. Go through, double check it, especially if you have like a second or third shift that you're following up, you're working behind. They may have made some adjustments. They may not, something might happen to that machine. So, it's always a good practice to check over your machine, check over your equipment every day before you fire it up and start using it. Hell, I've even come back after lunch and find somebody's messing with my machine, and I had to go back through it and fix everything up because somebody's working on like a government project or a side deal, during lunch. So make sure everything's set up correct. All of our connections are secure. Contact tip's good. And you shouldn't have any issues. Your machine should, run pretty much optimal at that point. I hope you guys enjoyed the episode. If you found value in it, please share this with somebody. Once again, if you have any questions you'd like answered on the show, feel free to shoot me an email, show@arcjunkies.com, or simply send me a DM on Instagram @arcjunkiespodcast. And if I use your question for an episode, not only am I going to give you credit in the episode, I will also send you an Arc Junkies sticker pack. Be sure to tune in every Monday for new episodes of the Arc Junkies podcast, every Tuesday for new episodes of Just the Tip, and the first Wednesday of every month for Weld Wednesdays with AWS. Stay safe out there, and until next time, make every weld better than your last.